Hi, this is Rob showing the latest version of the GlussPusher. I'm going to start the same program running that I used last time to show it. It just moves back and forth at varying distances and then stops. I tried to tie it to a potentiometer here on my little Arduino pot, but something's going wrong as usual. So I had to revert to this previous program. I'm a little disappointed that I actually had to slow it down because there's so much less friction now that I have 3D printed the stator part, that I actually have to slow it down to keep it from overshooting. So I need to get that dialed in later. Here you can see a 3D printed part which I started with. This was an early model. It contains little slots to hold the part of the stator here, which I'm working on. The people at Tech Shop where I did this were very, very helpful, but there was something wrong with the machine, so it took a very long time to get this printed. But it's now been published on Thingiverse, and anybody can use it. There are some weaknesses, but I like the 3D printing system because it makes the stator part repeatable. This uses a carbon fiber tube for the magnets, so you can't see inside it like the acrylic version that I used to use here. One of the things I like about the 3D printed version is if someone wished to, they could print a version to make a model that would accept this smaller diameter rod that has 1/8 inch diameter magnets in it instead of 1/4 inch diameter magnets, because it would be kind of fun to have one that was smaller as well as one that was bigger. Additionally, I'm using this, I printed it as an octagon here so that I would have flat places to mount circuit boards to for what I'm trying to do. I believe that today the system is very unreliable, so I'm working on an idea of using an inexpensive photoresistor to detect light in this back tube to try to make a closed loop system rather than an open loop system. Right now, if something goes wrong, if it overshoots or if a force prevents it from moving, it doesn't know how to correct itself. It's a completely dumb system. And I don't, that's useful for certain applications, like if you're doing some cosplay or art thing where you're controlling it by hand, it would be okay. But for robotics, that's not really going to be acceptable. So I'm going to have to work on some kind of a sensor-based system to tell where you are. You'll notice that these coils are not exactly the same size. That's because I sort of fell asleep while I was winding them, which is not really very good. They should be the same size. And I'm using much thinner magnet wire than the previous coils I used, which is good because they draw less current. So now at 12 volts, and I'm planning to mount a 12-volt battery on here somewhere, probably a lithium-ion or lithium-ion polymer battery. We have enough power, we have enough force to at least move ourselves, and we can go up to 24 volts if we want without drawing more than 2 amps, which the relay board, which I'm using over here, is the limit, and it'll shut off if you try to use more than 2 amps. It's actually a little tricky to design coils. I'm writing a little paper on how to do that. Basically, you choose the magnet wire diameter to stay within your amperage limit, depending on what you're doing. But I have not, since I moved to these smaller wires, I haven't had any problem with them overheating or drawing too much current. There's a relationship between current and number of turns that you want to balance in some circumstances. So I'm pretty happy with the 3D printing part now that I got it done, this part here, although I need to make some improvements. You may be able to see the blue marks where the system stops. It stops exactly at each of these step points, and they're not even, and I think that's because I made these coils actually a little too wide, wider than 1/2 inch, so I'm going to modify this model to make these coil spacings even shorter. So they'll be a little bit shorter than 1/2 inch, which should hold the magnet directly in place and hopefully be regular. I think the reason these are not lined up is because this coil is too broad. At least that's my theory. Thanks.